So in this video, I'm going to show you how some of the non-exact ODEs, not all, okay, some of the non-exact ODEs can be changed into exact, okay, by multiplying by a certain function and then solve it by using the method of solving the exact ODEs, okay. So our goal here would be, how do we find out a suitable function to multiply the given ODE so that that ODE will be exact after you multiply, and how do you solve that? Okay, so that's what I'm saying here. Some non-exact ODEs can be made exact after multiplying by a certain function, let's say mu xy. Okay, suppose you have an ODE that is m plus n dy over dx equals to 0, and suppose that this is not exact. Okay, now this is not exact, and so we want to find out a function mu xy. So finding a function mu xy, so that after you multiply this, the whole thing, m is also a function of xy and n is also a function of xy. So if you multiply this by mu, then you will get mu m plus mu n, right? And then dy over dx. If you do that, it will become exact. So if it is exact, then you need so the derivative of this with respect to y and the derivative of this with respect to x must be equal, right? So then after you multiply that, you will get exact form, meaning that it will be mu m, mu and then times m of y is equals to mu times n with respect to x, right? That's what you will get. Now if you find out the derivative of this, like product rule, what do you get? You get mu sub y times m plus mu times m sub y, right? Equals this, all this sub y sub x will be the partial derivative, okay? And then mu sub x times n plus mu times n sub x, okay? Let's bring the things on the left hand side. What do you get? So basically you will get mu y times m, okay, minus mu x times n. You see that? And then plus, so you can write my minus nx, right? If you bring everything and then write mu, because this term and this term has mu in common, equals to 0. You see that? So this form basically will be the exact form there, okay? This will be the exact form. So, but you know, one of the thing is, so the thing is, it is very hard to find out the function mu if it depends on both x and y, okay? If this function mu depends on both x and y, it is hard to find out that. But if this function mu depends on only one x or only one y, then it may be easier to do by hand, okay guys? Let me write down the node, okay? So this mu function is not unique. There may be more than one mu function exist, okay? So the function mu xy is called integrating factor for the exact equation, okay? Called integrating factor, and is not unique. Maybe you can find out two different integrating factor there, and then when you multiply, you can make it exact, okay? Another note I want to write is finding mu xy is not easy, okay? So it is easier if mu is just a function of x. That's what we will try, okay? We will try as mu as a function of x and then do it first, and then we'll try mu as a function of y and then do it if mu function of x is giving you the complicated expression, okay? We'll see in examples if mu is equals to mu sub x. In this case, in this case, what you get is, suppose mu is a function of x. In this case, what happened is mu sub y will be 0, right? Because if mu is function of x only, then mu sub y will be 0. Then you will get what? You will get negative mu sub x times n, okay? And then plus m sub y minus n sub x times mu equals to 0, right? Equals to 0. So what do you get? So if you solve this, you will get n. So you will get like this, okay? So you'll get mu sub x, that is partial of mu with respect to x, is equals to, you can write m sub y minus n sub x over n, right? If you solve for mu sub x, what do? You just move this to the other side, you'll get negative sign, and then you cross that negative sign and divide by n, okay? So that's what you will get, mu my minus nx over n times mu, okay? So we can solve this equation. So you can solve this equation by using the separation of variable or the linear, because you can think of this as a linear equation, right? Or separation of variable. So you can solve it by separation of variable or linear equation. Okay, so to find out mu, this is what you use. First of all, we consider mu is a function of x only, and then do. Sometimes when you consider mu is a function of x only, this equation may be harder to solve. If this equation is harder to solve, then we will assume mu is a function of y only. Okay, guys. So what happens if mu is a function of y? Then in that case, if mu is a function of y only, then this term will go to 0, right? This term will become 0 because mu x will be 0. So what do you get? Similarly, let me write down. Similarly, if mu is a function of y, mu equals to mu of y, then so this mu of x will be 0. What do you get? Then you will get mu y times m plus mu times my equals to, you get mu times nx, right? So what do you get there then? So mu y is equals to mu my nx minus my, right? So you get, because you will have to move this to the other side, nx minus my, okay, divide by m. That's what you get. You see that? So nx minus my divided by m times mu, right? So this is the formula you will use to find out mu if this is complicated, okay? So after you do this, then you can find out the mu, okay? All right. So, and if mu is a function of both x and y, so it is harder to find out, but we will see, we will do, most of the problems we practice is either mu is a function of x only or mu is a function of y only. So next, let us see some of the examples on how do we use integrating factor to make a non-exact equation and exact equation. Okay, guys. So let us do first example. The first example I want to do is, okay, let us look at this example. It says check if the ODE y plus 2x minus y e to the y times y prime equals to 0 is exact. If not, find the integrating factor to make it exact, and finally solve the ODE. Okay, so to check exact, first of all, what we need to do, solution is, what is m? M is y. What is n? N is 2x minus y e to the y. So what is m sub y is 1, and then what is n sub x is 2. So not exact. Not exact. Okay, so what we do next is we need to find out the integrating factor. Let mu equals to mu of x. Mu is a function of x only. Let us suppose that is the integrating factor. We need to find out the value of this. Then what do we need to do? Do you remember what I wrote the function, the equation for mu when mu is a function of x only? It was what? It was d mu over dx, that is mu sub x, right, is equals to m sub y minus n sub x over n, right? M sub y minus n sub x over n. So what do you get? You get what is m times mu, right? So what do you get? What is m sub y? M sub y is 1, right? And minus n sub x is 2 over n is, what is n? 2x minus y e to the y. That's what you get. You see that? So what do you get? What do you get finally is, so d mu over dx is equals to negative 1 over 2x minus y times e to the y. Look at this. This sounds like it is harder to solve, right? Because it is not separable form. Because what do you get? The final version of this, d mu over dx equals to negative 1 over 2x minus y times e to the y. Okay. So why did I assume that mu equals to mu x? Because I was just trying whether it will make the problem easier to solve. Okay. See, this one is harder to solve. Why? Because it is not, it cannot be, I mean, it is hard to written as a separation of variable, because you cannot write just y in one side and the x in the other side. Or it is not linear as well, because there is e to the y. Okay. So what we do here is, so let's stop here for this and then try let you can do mu equals to mu of y. Mu is equals to the integrating factor is function of y. Let us assume that way. Okay. If you do that, so what is the equation? Then what is the equation that I wrote? I wrote the equation as d mu over dy, d mu or mu y, right? D mu over dy equals to n sub x minus m sub y over m times mu, right? That's what we did. So what do we write then? So what is n sub x? N sub x is 2 minus m sub y is 1 over m. What is m? M is y. Oh, that is good. Times mu. You see that? So you got d mu over dy equals to mu over y, which is easy to solve because you can just change this into the, you can change this one into the separation of variables, right? So what do you get? Then you get mu xy equals, so let us do that. So 1 over mu, this implies 1 over mu d mu equals to 1 over y dy, right? So what do you get there then? So you get, if you integrate this, you will get natural log of mu equals to natural log of y. Okay, so plus natural log of c you can write. Okay, so if you want to, you can write that way, or just you can skip that c, because if mu is a function is because what do you get? Plus, you can say that constant will, let's say, natural log of c, right? You can do that, right? So when you combine that, you will get mu equals to cy, right? Because if you combine that, you will get natural log of y times c. So natural log and natural log cancel out, or you can remove those and then you can write mu equals to cy. But if mu equals to 1y, 2y, 3y, all of these are the solution of this equation. So you don't have to write cy, just write mu, just take c equals to 1. You can write mu equals to y. So this is the integrating factor we got. Now what we want to do next is we want to multiply the whole thing by that integrating factor and then use the exact method to solve. Okay, so next, let's do next multiply the given ODE by mu equals to y. So what do you get if you do that? So you get, so your ODE will look like y squared plus 2xy minus y squared e to the y times y prime equals to, you get 0, right? That's what you get. So because previously we had just y plus 2x minus y e to the y times y prime equals 0. Now this should be exact. Is it exact? Let's see. What is m here? New m, okay? So m here is y squared, and then n here is 2xy minus y squared times e to the y. So what is m sub y? M sub y is 2y. And what is n sub x? N sub x is 2x. So there it is exact. Then this new equation is exact. Right? So we need to find psi xy, so that what is that? Psi of x must be equals to m, and then psi of y must be equals to n. So we need to find out those the value of psi, so that satisfies that one, right? So similar to the previous one, after you know that it is exact, then you do exactly the same way as previous one. Okay, now what we do is we take the first one, okay, and then integrate this. So what is that? Psi of x equals to what is m? M is y square, right? Now integrate this with respect to x. You get psi is equals to y square x plus h of y, right? Now what you do is you find out the derivative of this with respect to x, y. So psi of y, because I want to use that thing, is equals to 2xy plus h prime of y. You see that? So what is psi of y though? Psi of y is n, right? So n is what? N is 2xy, that is 2xy minus y squared times e to the y equals to 2xy plus h prime of y. You see that? So what do we do next is, now see, if you subtract 2xy from both sides, that's what you get. So what do you get? So you get negative y squared times e to the y equals to h prime of y. You see that? That's what you get. Now we need to find out the hy, right? Because after you find out the hy, you are done, because you will plug in here. You see that? So how do I find out hy? We need to integrate on both sides, right? Therefore, h of y is equals to negative integration of y squared times e to the y dy. So do you remember there are several ways that you can do the integration by parts, right? One way is you can write just like u here and then dv here. U is y square. Let's write out negative y square, that will be easier for you. And then the v is dv is e to the y. Now find out the derivative of this. So what do you get? Derivative of y square with respect to y will be negative 2y and then negative 2 and then 0, right? So this one will be, all of them will be e to the y, e to the y, e to the y, and then e to the y. So the derivative of this will be, integral of this will be e to the y all the time. So we need to find the derivative of this, integral of that one. Okay? So what do you get is, you need to just do this multiply with that will be positive, this multiply with that will be negative, this multiply with that is positive, this multiply with that with negative, right? So if you compile those, this guy will be basically negative y squared times e to the y, negative y squared times e to the y, right? And then minus 2y times e to the y. So minus plus, because there is a negative multiplication, plus 2y e to the y, and then minus 2 e to the y. So basically what you get is, you get negative y squared plus 2y minus 2 times e to the y. That's what you get for hy. So what is the final answer then? Therefore, hence you get psi of xy is equals to, plug in that here, y square x, or x y square plus e to the y times negative y square plus 2y minus 2. That's the psi. So what is the very final answer then? The very final answer will be psi equals to c, right? Why is that? Because the purpose of this is finding a function psi, so that is the derivative of psi with respect to x is equals to the whole thing. So if you write like this thing as d psi over dx, then the integrating of this will be psi equals to c, right? So you write hence, therefore psi x, so let me write the solution is xy square plus e to the y times negative y square plus 2y minus 2 equals to a constant c. That's it. Okay, guys. So you can, I mean, that again, as we mentioned, you can write c1 here and then plus c1 here, and then that is just a c, because this whole thing equals to another constant k, right? And then just subtract c1 from k will give you c. So that is the final answer for this problem. Okay, guys. So let us look at this example. This is a question number 25 from your textbook. So actually, so the idea here is, first of all, we need to test whether it is exact or not, right? So first, let me write down that first check if it is exact. So first we check if it is not exact, and then we'll try to find out the integrating factor. So to try the integrating factor, first thing you do is you try if mu equals to function of x work, or make it easy. If it is hard to solve, then we will do mu is function of y, that we did in the last example. Okay, so let us try solution. So here m is equals to 3x squared y plus 2xy plus y cubed, and then n is x squared plus y squared. So what is m sub y? M sub y is 3x squared plus 2x plus 3y squared. What is n sub x? Is just 2x. They are not equal, so not exact, right? Not exact. So let mu equals to mu sub x. So this is the default thing. First we try mu equals to mu sub x is the integrating factor, right? Then if it is the integrating factor, then what do you write? Then mu over dx is equals to, you write m sub, what was the formula there? M sub, so m sub y minus n sub x over n, right? So m sub y minus n sub x over n times mu. That's what you solve first, right? What is m sub y? M sub y is 3x squared plus 2x plus 3y squared, right? Minus n sub x is 2x, right? Divide by what? N. What is n? N is x squared plus y squared. What do you get? And then there is a mu times mu there. So what do you get? That 2x and negative 2x cancel out. What do you get? 3x squared plus y squared, which is nice, because you got x squared plus y squared in the denominator, right? Plus y squared, so you cancel out, so it is 3. So mu is basically the 3. So if you multiply this thing by 3, the whole equation by 3, oh, by the way, this is, hold on, 3 mu, right? 3 mu. No, I should not forget that mu. So what do you get? D mu over dx, right? Now let us solve this for, so therefore d mu over dx equals to 3 mu. How do I solve this? This separation of variable, 1 over mu d mu equals to dx, right? 3 dx. So if you integrate, you will get natural log of mu equals to 3x plus c, but you don't need to consider c here, because you will get basically c times something, right? So let's take c equals to 1. What do you get? So you will get mu equals to e to the 3x only. Okay, so this is the integrating factor. What do we do next? You multiply this by the integrating factor. Let us do that. So you get e to the 3x times 3x squared y plus 2xy plus y cubed plus e to the 3x times x squared plus y squared times y prime equals to 0. So this is exact. So you don't have to check for exactness. This will be exact equation, okay? Because the whole purpose of doing this is making this equation exact by multiplying by the integrating factor. Okay, guys? So how do I solve this exact equation then? To solve, we need to find psi xy, so that, so psi sub x equals to m. What is the m? The new m. This is the new m, and this is the new n. Okay, and then psi sub y is equals to n, the new one. Okay, so so if you want to write, you can just give the just little hat there. Okay, because just to mention that this is the new one. Okay, so what is psi of x equals to what is m then? So m is e to the 3x times 3x squared y plus 2xy plus y cubed. Now we need to integrate this with respect to x. Okay, guys? So to integrate this with respect to x, what do we get? We will get, so basically you will have to use product rule there, okay? You will have to use product rule. So let us write in the integration form, psi is equals to, so you write 3y, because when you integrate with respect to x, y will be a constant, so I pull that out, x squared times e to the 3x, okay? And then plus 2y, and then you need to distribute that, you get x times e to the 3x, and then dx, right? Dx plus you get, what do you get? Y cubed times integral e to the 3x dx. This is what you get, okay? So what do you get there then? So just use the integration by parts as we mentioned that. You do u and then dv. U is x squared, right? And then dv is e to the 3x. So if you find out the derivative of this, it will be 2x and then 2 and then 0. Integral of this will be e to the 3x over 3, e to the 3x over 9, and then e to the 3x over 27, right? So if you do the positive and negative multiplication, what do you get? This is the positive multiplication, this is negative multiplication, and this is positive multiplication, right? So what do you get there for this one? So for the first one, you will get 3y times x squared e to the 3x over 3, right, minus 2x times e to the 3x over 9, right, plus 2 times e to the 3x over 27. That's what you get for the first one. For the second one, what do you get? Plus 2y times, okay, 2y times, how about x and how about the x and let me erase that. How about x times that one? So if you are doing, there is a 2x there is a 2y and then x times, right? So it will be u and then dv, right? And then u is, you write x and dv is e to the 3x, right? So x1 and then 0, so e to the 3x is e to the 3x over 3 and then e to the 3x over 9, right? So what you get there is basically 2y times the integral of this. It will be x times e to the 3x over 3, right? And then minus, because this will be plus, this will be minus multiplication, right? The first one will not have any pair. So you get e to the 3x over 9. And then plus y cubed times, what is that? E to the 3x over 3 and then plus h of y. Look at that. A lot of things there, right? So let us, so if you simplify this, what do you get? Let me simplify this. You need to distribute this, right? You will get x squared. So all on the top there is e to the x out, right? E to the 3x out. I'll write down that later. So what I want to do is I want to distribute this inside. So you write x squared times y, 3 and 3 will cancel out when you distribute this, minus 3y times 2x. Oh, there is 3 and 3 will cancel out, so you'll get xy, and then there is 2xy. So 2xy divided by 3, right? You see that? 2xy divided by 3, because 3 and 3 will cancel out. And then plus 2 and then y divided by 27 times e to the 3x, right? That's the first one. Plus the second one will become, so that 3 and 3, so there is no 3, so you will get 2xy over 3. You see that? 2xy over 3, e to the 3x is outside, minus 2y over 9. You see that? Times e to the 27. e to the 3x, and then plus y cubed times e to the 3x over 3 plus h of y. Okay guys, that's what you get. By the way, this should be 9, right? This one should be 9. You see that? By the way, this one should be 9, right? This one, because when you multiply this one, when you distribute this one, here that 3 and 27 will, 3 will, if you divide that, will be 9, right? Now, what we are going to do next is we want to just see all of these have e to the 3x common, right? You can take them common out. What will cancel is there is a positive 2x over y over 3, there is a negative 2x y over 3, there is a positive negative 2y over 9, there is a positive 2y over 9. What is left is x squared y and then plus y cubed over 3 and then e to the 3x, right? And then plus hy. That is, you get psi xy equals to, you get x squared y plus y cubed over 3 times e to the 3x plus h of y. That's what you get. Okay, now we want to use this thing because we use this already, so we want to use this in. So multiply this by both sides by y. You get what? Psi y equals to x squared plus y squared and e to the 3xy, because we are finding with respect to y. This is a partial derivative. Okay, we are finding with respect to y. That's why it will be x squared times y. Okay, and then plus the derivative of y cubed will be 3 y square, right? So 3y square over 3. 3 and 3 cancel out. So e to the 3x is just like a constant. Plus h prime of y. You see that? This is plus h prime of y. But what is the value of psi of y? Psi of y is equals to n. What is n? N is this thing, right? So you get e to the 3x times x squared plus y squared equals to, x squared plus y squared times e to the 3x plus h prime of y. Wow. So if you subtract this, you will cancel out that one, right? So what do you get? H prime of y is equals to 0. So what is h of y? Is equals to a constant c. You see that? So what you do next is you will plug in that h of y. Where do you plug in that h of y? Is basically right here. Right here. Because this is the simplified form, right? So this is the simplified form where you plug. Hence psi xy is x squared y plus y cubed over 3 and then e to the 3x. Okay, and therefore, so the final solution is psi xy equals to c. You will get x squared y plus y cubed over 3 equals to times e to the 3x equals to constant c. You see that? That is the final answer.